Hello, my name is Keith Jeffery. I hold honorary professorships at Cardiff University and Heriot-Watt University in the United Kingdom and at Masaryk University in the Czech Republic. I worked on early database systems, interoperation of environmental data and later scientific applications, office automation and management information systems. One of my areas of expertise is virtual research environments, also called VREs. In this video, we address the fourth learning objective of the Open Government MOOC, namely to analyse and discuss benefits, barriers and potential negative effects of a particular open government case, including technological and judicial aspects. We focus particularly on the technological aspects of research data collected either by governments or funded by public money. More specifically, after this video, you should be able to A. Describe the origins of government research data, and B. Discuss how government research data can be analysed. We start by examining the origins of government research data. Research data in general may be acquired through several mechanisms, individually or collectively. Each has its advantages and disadvantages, and each may be inappropriate for certain domains of research. The good news is that most research data is now collected digitally, so manual transcription with associated errors and lack of immediate validation is avoided. It is generally accepted that data collected at public expense should be made available openly and without cost to the public. Furthermore, it is expected that the open research data will provide raw material to obtain new insights into phenomena. There are two main types of open data in general: open data produced by publicly funded research and open government data produced by government departments. The former kind commonly is large, complex, with associated complex software and scholarly publications. The latter may be derived from the former, especially in economics and social science, and is usually simpler in structure. This is the so-called data.gov domain, for example, data.gov.uk. Open data and open government data are usually licensed using the Creative Commons CC-BY. The BY means with attribution, but others are possible. For example, NC means non-commercial. Whereas open data is usually available in computer actionable form, open government data as yet is commonly as PDF documents, which are more or less useless for computer processing, except for reading, copying and transmitting. It is hoped that progressively open government data will be made available with metadata and data in useful digital form. It is commonly stated that research data in general has the 5 V's as characteristics. The variety refers to the heterogeneity of representation, character set, language, such as Dutch, syntax, structure, and semantics, meaning, as well as representation format and the medium, such as disk, used for storage. The volume is the size when stored or transmitted, from kilobytes, which are thousands of bytes, to yottabytes, which is 1 followed by 24 zero bytes. Velocity refers to the speed of data acquisition or transmission and has implications for processing. For example, conventional data querying requires a static dataset. So for streamed data, the query has to act over defined windows or intervals in the stream of data. Validity concerns how well the data represents the real world and is usually controlled by various integrity constraint checks or validation. As an example, a validity check might state that the temperature at the Earth's surface cannot be greater than 100 degrees centigrade or less than minus 100 degrees centigrade. Value defines how useful the dataset is to the end users and may be measured by feedback comments or likes as used in social media. This brings us to our next topic, namely to discuss how government research data can be analysed. To perform data analysis on existing data, there are several steps. First, a relevant dataset has to be discovered. Once one or more are discovered, they require contextualization in order to assure the end user that the dataset is in the relevant domain, for example, biomedical, that it has the appropriate coverage in spatial and temporal dimensions, that it has sufficient accuracy for the intended purpose and associated appropriate precision, and that the quality is sufficient, usually based on information about the research method and the researchers themselves. The next step is the connection of the software to the data. This may be done through an application programming interface or may first need conversion of the data to a form suitable for the software. Then the analysis can begin using appropriate statistical techniques for data reduction and characterization, for detecting correlations or properties of the dataset, and for predictions. Simulation software may be used either to produce a matching predicted dataset for comparison or to extend the existing dataset as predicted values in appropriate coordinates such as space and time. Finally, it is common to visualize the data as graphs, scatter plots, or even virtual reality. Augmented reality is achieved with graphics superimposed on the user view of the real-world artifact or scene of interest. It is very useful in archaeology to visualize reconstructed buildings on top of the real-world rubble. Virtual research environments, or VREs, bring together open and closed data, appropriate software, and researchers communicating using immediate means such as video conferencing and social media, and non-immediate means including scholarly publications. Usually, the researcher follows one or more workflows or sets of processing steps connecting datasets to the software services to achieve the desired results. Along the way, the researcher interacts with colleagues and records in a laboratory notebook, ideally electronically, the work done. Finally, this is presented as a scholarly publication. Ideally, the researcher can also, from the same environment or workbench, perform the necessary administrative or management tasks. The challenge of VREs is to be able to integrate the heterogeneous data, software, computing resources, scientific equipment into what appears to the researcher as a homogeneous system. To achieve such integration, metadata is required to discover, contextualize, and connect software and resources to the datasets to be utilized. In order to conduct e-research with open and government data, we have to describe to the system, using metadata, the user, that is the person, the processing, the software, the datasets, and the resources, such as computers and research equipment, within models to represent the real world. This then allows appropriate middleware to take all this information and produce a workflow with appropriate security, privacy, performance, and costs to achieve the research objective of the researcher. In this way, IT can provide the appropriate support for the researcher, whether they are in a university or research laboratory or an amateur citizen scientist. There are exciting research projects in Europe and more widely tackling these problems right now. The EPOS, European Plate Observation System, is providing a VRE for all earthquakes and volcanoes in Europe. The ENVRI Plus project is doing something similar for the natural environment. Passage is providing middleware to enable dynamic redeployment of applications and workflows across multiple cloud computing platforms. Finally, the VRE for EIC project aims to provide the definitive VRE architecture and software components. References to these projects are available here. Thank you for your attention.